Hello and welcome to the first chapter of the Apocalypse Inferno. As you have seen in the introduction video, we're going to build a layout with procedurally generated buildings. We're going to crack open the landscape, and the buildings will follow that animated landscape, and they're going to fall down, and we're going to set all that up in the TOPS network. But as with always, we're going to start with creating our project folder. So this is usually where I create my project folders. You can, for the new starters, there's a file button here, and then you can go to new project, and you set your project path. If it's on Windows, you put it to whatever you require. I have my work folder under my home, so that's what I'm going to do it now. And then I have Houdini projects. So if I go here, Houdini projects. Now let's call this Apocalypse Inferno. Since I have always worked on Linux environments, I tend to not leave spaces, so use underscores instead. I don't think it breaks anything, but it's just a habit of mine. Because Linux is a bit more different than Houdini when it comes to command line with the namespaces and the spaces in between the characters. So yeah, I always use an underscore. Okay, and then you click accept, and then you will have your folder created. Now let's do a file save as. Now if I go to $job, this is going to end up in the folder Apocalypse Inferno under Houdini projects. Oh, this is not actually the right place, sorry. Let's ditch that. Let's create it again. It's not under my work folder. It went under my user folder. Let's remove that. Okay, I deleted it. Let's do it again. New project. I want this under my work folder, Houdini projects folder. So it's gonna be somewhere here. Accept work Houdini project. Okay, so then you can see it here. It added one extra, which we don't want. Let's get rid of this. Okay, then let's name it Apocalypse Inferno and say accept. And now if I bring my folder here under my Houdini projects, I'm going to have an Apocalypse Inferno. It's empty now. Let's do a file save as, and let's call it 01 landscape, and then we will continue like 02 building generation, 03 rich bodies, so on and so forth. It kind of makes more sense. It actually didn't say no such file. Did I not create? Wrong place again, my bad. Save as. Let's do the job. Now it's under Inferno. Okay, now it's in a good place. 01 layout or landscape accept. Okay, so now we are ready to go. So let's start by dropping in geometry node, and just to show you what we will focus on first is this guy here. So that's the terrain node, the very first node that we're going to end up creating, which is a very simplistic one here. There's a cached version here, and this is what we're going to get. I'm just going to walk you through it. There's 3 or 4 easy nodes. Let's name this node terrain, and let's drop in a height field, standard height field node. This is just like a 2D volume field. It's a height field as they use it. If you want to get further information, you can press this guy, and it's going to just give you the available documentation. You know what they are? They are 2D volume primitives. They're really fast. Houdini can understand. Majority of the solvers can understand what these are. These are available for a while now. Anyway, so my grid spacing is basically this is my detail for my render mesh. It's 0.5, and my size is 1000 to 1000 meters. That's 1 kilometers. then I just edit a noise, height field noise, search for it, it's this guy, plug it in, so the output goes into left input is accepting height fields, right is accepting masks. Okay, so my amplitude is by from either scene is 300 to 468. So we will copy these settings as I prepared, so we can have like a very similar output. Of course, you are free to punch in any number you want to your liking, but I suggest following this up A to Z first to get somehow similar results as I did, and then to deviate from that if you like to. So this is pretty much it here. The next thing is the Erode node, which is very cool because it kind of like creates a bit more natural progression of layers. So these may require a manual put because it's gonna take, I think, a little while. So let me put my other scene on manual as well. So let's plug in the output of the height field to Erode node. Let's turn on the flag. So my simulations, my scenes are usually so this scene I made is from starting from frame 1000 to 1500. So this is what we do by setting our frame range. So I would like the simulation, the erosion simulation, to be done by 1020. Okay, so my advanced settings have, I think, somehow some differences. No, I think they're pretty familiar. I'm just gonna set the same seed so you get the same exact result. No other attributes have changed here, and the simulation will start from 1001. And now I'm gonna let that cook, and as you will see, it will start passing frames. So let me now pause the video. This shouldn't take long though, and I'll get back to you once it's done. Okay, so it's cooked. I think it's kind of, yeah, it looks quite similar to what I did. Let's put a null here, and let's write it out, height field. I usually make my out nodes black and circular, so they're easier to spot. And then we need to cache this guy, file cache. So here's the thing, it's about using environment variables on how to set up your cache spaces. Because I have quite a few hard disks, like I have a fast one, I have like a really fast one, where my swap is, where my Redshift cache is. I have like a really slow one that's like much bigger, but it keeps bigger disk space, so on and so forth. So instead of going like every single time media, price code, work fast, so on and so forth, and forget what is where, what you can do is that you can go into your Houdini 18.5 folder, and in there you will find your Houdini environment file. So if you open this, you can define things like, let's try to make this a little bigger for you guys. This should work. View, make it bigger. Well, I'll open it with another tool so we can zoom in case it's not very much visible. Yeah. So here you can define such things like fast cache, that is pointing to my folder that is a RAID 0 disk that is 2 NVMEs. It's like ridiculously fast. And then I have my cache, which is just a hard disk, and I don't have an SSD that can that's more than usually you need some space for this tutorial, let's say at least 1 terabyte. I don't have such a big SSD, so I kind of keep my long-term caching on my slower disk. They're not that slow, but they're good. Okay, let's close this down. But at this moment, this is not that important, so I'm just going to call this, because this is not going to be reading per frame. We're going to do a lot of other things down the line for this guy. So let's cache this now. Meanwhile, I'm checking the time, which is fine. Okay, so I think I'm going to keep this under hip. But the way I do some of these namings is a bit different. I go geo $OS, and this is a static one, so I call it static. And only one frame, save it to disk, load from disk, and so it won't change from here this moment forward. Let's move down. So now I want to convert this to geometry, because we're going to do a lot of other things down the line. Let's convert this to polygons. I named the density to 0.25. Is it a bit too much? I'm not sure. Let's check. 0.25. Okay, no, it's just the density is a lot less detail. Let me see if I can. And we need to make that thicker because we're gonna break it. So let's go extrude base. All good. And I believe I painted this somewhere in the center, something like this, so we could break it. It looks like my my other old scene, the paint values are gone, so let's be careful about that. It's probably better if you cache it out. I'm going to pause my other scene. All right, extrude base. Now this is extruded, kind of like it flattened the bottom. So let's set this to depth to 100. So it's 100 meters deep. And okay, so it's just deeper now, which is good. So I'm going to do an attribute paint now, because in our simulation we are kind of like breaking through this line, right? No, actually, yes. So on which axis? On Z axis. So it's going to be something like this. So we're going to paint through here. So let's drop down an attribute paint node. Attribute paint. Okay. And if you turn on the visibility flag here, move the mouse over to the viewport, hit enter, you should get like you're ready to paint. And then if you hold shift, drag your mouse to the right, it should have changed the size. It's not this one. Okay, maybe not anymore. I'll change the radius, then it's going to be easier. Let's change the radius to 100. I wonder if the shortcut changed. I think it was shift right and left. Maybe not anymore. Okay, and then just paint through this like a straight line. So like again, if you follow this scene, you're gonna end up having exact same thing as I had. If you don't, you're gonna have something different, but this is not really the important topic here. So let's go scatter. Let's put scatter here, and then we're going to change density to mask. And now this is probably 1000 points, and yeah, it's all good. Now let's put a RBD material fracture node. Wait for it to cook. I don't want points in this edge, so I'm going to get rid of those. Actually, I think no. I don't want to get. I don't want points in the edge. So let's just select them. Not everything. Remember, not everything has to be procedural. Okay, let's delete these guys as well. We just painted a little too much on the edges. Okay. All right. So let's put this on manual. Let's go. Left input goes to material fractures first. Output from convert height field goes into the first input of the material fracture. The impact points, Erode Node points, goes to the R points. And now we need to give this a namespace. I turn on the fracture namespace. I go land. I'll show you what that means once the cooking is complete. Scatter points. Let me see. I scattered is only one, so just one is good. The values were set to fracture ratio is 1, volume scatter point is set to 100, seed is 1.25. I'm just trying to get everything similar. And input is turned on. Volume resolution was not touched. Let's go to detail. Detail size is 3 meters because our object is like 1 kilometer. And let's turn on edge detail. Noise height is set to 100. Please feel free to experiment with these values. I have an interior detail again. This time the depth, volume, voxel size set to 5. Noise amplitude set to 20. Sparse convolution is fine. 0.05, 0.05, 0.05. These are just setting up some details. They're not that really important. So now I'm going to turn the flag on here. I'm going to set this to auto. And I'm going to pause the video and I'll come back once it's done. They usually take around like 30 seconds, 1 minute, maybe 2, depending on your CPU. At this stage, it's not really, we're not doing anything heavy, to be fair. Let me pause now. Okay, so we continue to break these. However, I noticed that, as I said, it's not that quick because this is a lot of polygons. So I just, for testing purposes, I turned off the edge detail and interior detail. And now what I'm going to do is, which we want those things to be on. So let me see this, because we're going to break those things again. What we can do now is I'm going to do an explode on my other piece to see that, make sure that this is the current situation. So basically we want to end up with something like this. Oops, yes. We want to end up with something like this. So, which we are not far off. I think we're just going to have to turn on the edge detail and it will get us there. So let's put this on manual again. This time I'm going to put on all here because I'm going to cook it to this directly. So let's call it all terrain. Okay, again, black around it. I'm just gonna copy this, copy, paste, and I will call this terrain. Sorry, terrain factor 01. I'll go manual. I'll turn on these guys again as I had on my other scene that is already capturing this. Okay, same settings, 100, 1.29, 100, 100, interior 5 to 20. It's called land, and that's pretty much it. So I'm just going to file, save. I'm gonna put it on manual. It's on manual, and I'm gonna give this a proper name, which is, it's fine because it's still a static one because it's going to inherit the folder name from the object name anyway. So this is all good. Let's hit save disk, and now I'm going to pause the video again. I'm going to wait until this is completely over. Okay, we finished cooking, so it's kind of very similar, I think, despite that we lost the original attribute paint from my original scene, but it really does look similar. Okay, let's continue. So this cached out. Let's make this guy again. Okay, I'm going to make these again the same color, so it's kind of like in and out points are set similar. Okay, so now what we can do is that, actually I think I also use the original height field at some point. Shift S is the one that tells you how the curve should be drawn. This is how I usually use it. So there's a direct output I made in my scenes called to scatter. So this is a height field, right? And also, let's put this on manual. There's another geometric output that is not extruded with the density of 0.5, and I name this one out terrain height field to geo. Okay, just like this. Again, this also rounded all of my nulls. Should find a default way to do that. That will be easier. Okay, so next thing, we're going to generate a proxy in a simulation area. So let's make another null, and we're going to name it from the fractured guy here, proxy. Come on, proxy. And now I'm going to pack this by name. So at this point, let's load the geo. Sorry. So if we go to primitives, you're going to see the land height and some numbers. So it's like based on this. If you do the selection, and then if you go to this guy up here, this guy, then if you go to name attribute, then you're going to see that it's going to select by name, like as a whole, even though these are at the moment not packed objects. It's going to isolate the selection based on name. So this is what we want. Now what I want is that I want to create if I go to, for example, this wireframe view, you can see that there's a, you know, our broken area is here. This is where we're going to make the land go right to the left. So let's create a simulation area. Now this is going to be sorry, we want to pack this first. Pack by name. So let's put a pack node. So what does pack does, if in case you need the information, there's a quite extensive, I'll open another scene. Just give me a second, please. Split pane, tear of pane, packed. So packed objects are like optimized geometry that Houdini doesn't have full access to, but it has all the information that is needed to do the simulations and so on and so forth. I suggest you reading this part from the documentation really vigorously. It's very important as a general rule as well. For optimization reasons, it's also super important how to optimize things. So let's close this. Just pack geo. So what happens is at this level, our geometry is not packed. And how do we know this? It doesn't say anything packed. And we have access to all the points and primitives, vertices, and polygons, and all these other attributes, which we do not need. So we can pack this. So if I just put a pack object, it's going to say, oh, everything's packed into one thing, and there's a path attribute, but we don't need that. We don't want to do that. What we want is we want to pack per name attribute that the material fracture creates, right? And I do want to transfer the individual pack name to the packed object. Then if I do a middle mouse here, now I have 909 packed geometry. That means there's 909 objects here. And I can, if I can remove this, let me see the selection, remove. Okay. And now I cannot actually select individual vertices, but rather just the packed objects. All right, so I'm going to name this sim, and this is actually using bounding regions and bounding box, and I gave it the value something like this. He's going to select the central objects basically. So if I go like this now, and yeah, so it kind of like just creates what's in the center, that center, right? We can say points, okay, and it shows me that these are the selected guys, and these are now called in a primitive group named sim, okay, point group. So then I can put a split sub, and I can say use the sim. So it's just going to give me two outputs. By default, it's showing me the left. I'm going to put another null. I'm going to say in sim area. Why? Because I want to refracture these things to 1,000,000 pieces or something similar. Left side seems a bit too much. Let's kind of shrink that. I'll say no. Just gonna pull this to the left a little bit. I want to isolate those big guys. Okay, a little bit more. Okay, that's good. That's much better. Okay, so right side we're not gonna touch much at the moment, but this center part we want to refracture. Okay, because we do want to have a lot of detail in there. So what I want to do is everything is packed at the moment. So I would like to put a for each for name primitive. I'll put this down here. Now if I plug this guy here, it's going to loop through each object that is in here, right? And because this guy is saying bring in every object one by one matching the string attribute name. So it goes like, okay, I'm gonna bring in this guy, this guy, this guy, this guy, so on and so forth. So I want to unpack this first, these individual pieces. And if you want to test the individual pieces, you can turn this guy on and then you can move it around to do it. And then it's probably better if you test it like this, because sometimes when you're inside you may do things that may not update the output. So let's unpack this one object. So now Houdini has access to this information. Let's do an attribute delete. Actually, I put the attribute delete inside, but I think it's better if we put this guy here, because it's going to do a faster deletion, a faster process of attribute cleanup. I'm going to keep everything but UV, and there's nothing here. I want to keep the name. No, I want to delete the name as well. Oh, actually, I need the name. So my plan failed. I need to do this inside or even after, but this should be fine. Let's do it here. Okay. So here I have less attributes. UV is coming from fracture. So, sorry, UV is coming from the height field. If you look here, you should see one. Oh, sorry, they're in the conversion. Okay, so that's what I'm preserving. It's pretty straightforward, but let's keep it anyway. Perspective again. So I am deleting everything here. Less points. And then I'm going to delete all the groups. Group delete. Asterisk. Okay. So now we are ready for refracturing. So let's duplicate. Now let's put in a new Rbd material fracture. There are many methods of fracturing. I find this one to be the easiest with the latest available tools. You can do cutting through VDBs and so on and so forth. Okay, so my default settings is very similar to what it is, except I have a scatter points of 10. And I do have the detail turned on, but I don't have the crease waves turned on. I think I was using this for subdividing, but we don't need that. Let's keep it just in case I use it somewhere. So let me break this through now. Okay, let's see what it does. I did already. Let's put an exploded view. Okay, so we made smaller pieces. I am not going to add more interior detail. We can, but I don't think I want to slow this down any further. Like this is where we create the center parts of the landscape that are falling. So if you need further detail, you know, it's going to be like, we can name this inside landscape pieces fracture. So you know, if you really need that kind of detail, you can always come back here and play with the edge detail. The next thing I did was to merge these guys a little bit within themselves, which is then using Rbd Cluster. So let this cook a little bit. Yes, so if I go here, it's all separated. Now I'm going to put an Rbd Cluster. So it should kind of, I think, merge a few together. Maybe we need to change the values. So this, I'm going to turn off random detach, size 10, 10, fuse, dissolve. It's just for cleaning up. I think it didn't do much anyway. Let me see now. Not really. I think the sizes were not big enough. Maybe if we do more. Yeah, okay. So I had an Rbd cluster, but it wasn't really doing anything. So let's just get rid of it. I probably tested it to merge pieces together. Now the thing is, this loop is compilable, so we should probably compile it for the sake of speed. So let's do put tab, compile sub, compile block. Compile block basically takes all this and speeds it up based on the cores you have on your machine. I'm just gonna put this on manual again here, and this guy needs to be set to multi-thread when compiled, and that should do it. And then we need to turn this off, but I'm gonna save again, and we're gonna do the null. Okay, let's tie this up a little bit. This looks a little ugly. Let's call it out seam area. I'm going to delete everything that comes out from here, which is actually just, I'm not using the cluster, so I'm just going to delete name. I don't want name. And then I'm going to put in a connectivity swap. It's going to be named as primitive. We're going to call it name. It's going to be a string, and we can call it piece underscore. So if actually, I'm just going to show you with one only, so it doesn't die here to see what we're doing. What happens is sometimes when I do a lot of big fracturing, I end up having similar names. So when you do like a mouse over to show the packed object, and then you get it shows something else is also selected. So it's something, I think it gets really dirty as we fracture and fracture and fracture. So I tend to find it easier to create my own name later on. So for example, this is what it comes out with material fracture. There's kind of like this several layers of naming. I kind of find it to be confusing, so I instead create my own unique name, which is called piece here. We can call it rock, so on and so forth. And then I'm going to put a pack here, and I'm going to use the name again, and I'm going to transfer that again. We had a crease weight. What was it? Where does it come from? Crease weight. Let's get rid of the crease weight as well. We don't need it. Here, yes, it's here, and yeah. Okay, so now if I pack it, it's going to be 55 objects packed in here. So what I'm going to do now is I'm going to take this guy again, go down. This time is fracture 2. This is all good. I'm on manual. I'm going to, because I want this to process through all the 900 objects, so it's going to take a little longer. Let's turn off single pass and hit save to disk. And now we're going to wait for this to cook out, and we'll get back to you again. And now As you can see, the fracture is finished. We have quite a lot of pieces here, but not to be worried. It's a 45,000 pieces, but we'll have a bit more optimized workflow on how to simulate these guys. Okay, now I'm gonna cut this video here, and we'll continue the next one where we will start animating our split geo that we put a split somewhere here. So if I go another null here, and if I check this guy, it's gonna be the opposite. So we're gonna animate these guys, and then we will do the then we will start doing a little wedge to simulate these chunks separately. All right, see you in the next episode.